Hi, today we are going to learn compound events. Two very important things you need to distinguish here. One is mutually exclusive events and one is inclusive event. Two events, we call it compound events, happens, then they are not happen so at the same time, then that only called mutually exclusive. And that can happen at the same time, that only call it inclusive events. So for example, it's like this. Rolling one die and then got even and odd at the same time cannot happen. Even or odd. But at the same time, even and odd, impossible. So then we call it mutually exclusive. But like rolling a die, even number and then prime. Even and prime. Yes, because number 2 is even and then there's a prime number, so that's possible. Then even number events and prime number events, that's not mutually exclusive, which is inclusive. And then in that case, you need to memorize this one very important formula here. A or B, probability A or B, which is probability A, we call it union. Union, you can, that's or. Okay, you can have all possibility you're gonna add it. That's a union. And so union is probability of A plus probability B, but at the same time, all the time, A here, B here, A or B is this. Happen at this one time. Then this, all the time, this one, A plus B, but you count this much twice. So that much you need to subtract all the time right here. But when this mutually exclusive, this is a 0. So minus 0, you don't need to do it because this. So that's why you have another, looks like an equation, but just one equation. So P, A, or B. One of the events happen, probability is PA plus PB, and minus because you count this one twice, subtract N, A and B events. So let's see with the examples. So sometimes you use the Venn diagram is very convenient. So here, let's say U, which is a total 160 beauty spa customers, and 90 had a hairstyle, and 61 had a manicure. And there were 28 customers who had only a manicure. So we want to find the probability. Let's events possibility first. And total is here 160 customers. Among those, hair styling, so let's write it, hair styling, and then you write it here, and then manicure, write it, manicure equals, that means this is total hairstyle number you're gonna write here, and the manicure total, manicure is here. So what, 9 hairstyle, so right here, and then here, 61 manicure here. Then this 3 possibility right there, and this one means this part here, and which is manicure but not hairstyle. So this one here, this one hairstyle and also manicure. This is hairstyle and manicure. This is a hairstyle only because no manicure. Okay, so what does 28 customer only had manicure, which means here only, so write 28. Then this is a 61, this 28, then 61 minus 28, so this will be 33 right there, right? This is 33, this is 90, and 9 minus 33 will be here, that's a 57 right there. And then this outside, who didn't have neither hairstyle nor manicure will be there. But in order to find that, we need to find first, let's say find the number first, had hairstyle, or we call it union, okay, and manicure. We want to find out total number of head or manicure number, and then this is all the time head number plus manicure, and then all the time this you count twice, right? Here one time, here second time, so you count this one twice. So you want to subtract hair and manicure, right? So then head here, how many? 90. So 90 minus manicure is 61 right there, plus, and then minus both, that's a 33, right? When you calculate, So this is a sum. Okay, this is a 90, and then this is a 61, and then you subtract 33. That means 118. You calculate, that will be 118. That will be hair or manicure, like this, inside of this red one. That means outside neither is 160 minus that. So 160 minus 118. So that's what? The 42. That's a 42 right there. Then neither a manicure or hairstyle. Okay, so you can do it Venn diagram. Then you can do easy this. But now, but some event. So a drink company applies one label to each bottle cap, and then free drink, free meal, or free again. A bottle cap has a 1/10 probability of being labeled free drink and 1/25 probability of being labeled free meal. So explain why the events free drink and free meal are mutually exclusive. When you do that, think, because why? Free drink and at the same free meal possible? No, because one bottle cap has only one label, so they cannot have both at the same time. So this is mutually exclusive, right? So when there's mutually exclusive, first probability drink or is union, right? And then meal is what? Probability of drink plus probability of milk. But now subtract drink and milk, but that's a mutually exclusive, which is 0. So you don't need to put the minus 0, right? So let's find this one. 1/10 and 1/25. So if you make same denominator, multiply 25 here and 25 here, and then 10 here, 10 here. So 35 over 250, and then you divide by 5. That's 7 over 50 is the answer. Okay.